over 5, 19, 3.8, 3.8, yeah, okay, 3.8 inches per year. Did he actually grow 3.8 inches per year? No. Some years he grew faster than others. But on average, okay, on average, 3.8 inches increase per year. But not exactly 3.8 every year. Sometimes it was more, sometimes it was less. Okay. What if we wanted to calculate the growth rate at one specific age? For example, at age 10. So take a second, come up with an estimation. How fast was he growing at age 10? I'll give you 2 minutes. 2 minutes is a really long time. Come up with a number. I want a number. How fast was he growing at age 10? How many inches per year? At 10. It's only 1 point. But you have to come up with a number. Any way you want. Come up with a number that represents how many inches per year he was growing at 10. It's supposed to be a little bit interesting of a question. And then how did you get it, right? Come up with a number and then explain to me how you got it.
Really? But it was. What did they do? Wait, what?
Okay, if you have an estimate for 10, see if you can find an estimate for age 14.
Oh, that's when they take like other arteries and like reattach it. Yeah. But that's a bypass too. That's when they take them from like different areas and like. You saw like take it after. It looks like spaghetti. That's actually so cool.
All right, here we go. Who has an estimate for 10? All right, raise your hand. And who has an estimate for at 10? How fast is this boy growing? Yes. Okay, so she says 5.5 inches per year. I'm going to say approximately. How did you get that? So she looked at the change in y over the change in x compared to 0, 0, right? Assuming it started at 0, okay? So this is closer to the average rate of change from 0 to 10 because you compared it to 0, 0. So it's still an estimate, okay? But this is actually, I'm going to abbreviate AROC from time equals 0 to 10. So it's not quite just at 10. It is an estimate, though. Anybody else come up with a different number? I have all day. I'm going nowhere, guys. Another number. I'm going to say 5.5 is too big. I'm going to say 3.8 is too big. Okay, I'm going to help you out. What if I take this point here? What if I say 9 and 11? What if I use 9 and 11? They're kind of close to 10. What would that look like? You all have rulers now. Okay, what if I do this? What if that line, I just use that line to estimate at age 10? What if I did 9.5 years to 10.5 years? What if I did the month before your birthday and the month after your birthday? It's pretty close to age 10. Okay, so one particular estimate. Now, do you see the difference in these two lines? That's why I said 3.8 is too high. Because I can tell that this line is steeper than this one. So if I do this, what is an estimate? Looks really small. The graph, there's no grid. So it looks like it's maybe 53 to 54, right? Looks like it's maybe 1 inch per 2 years, right? Because I was comparing over 2 years, so maybe 1 inch to 2 years. So that is 0.5 inches per year. Just estimating. Now that's, I guessed the points, guys. I just guessed how many it went up. Okay? What if I would say t equals 14? So that is over here on the graph. Okay, there's 14. What would you guess for an estimate at 14? Any way you want. Guess. There's no grid, so do your best to figure out what those points are. I get 6.5. That's what I get, 6.5. Approximately, right? Approximately. But I get 6.5. See what you get. Okay, so I'm going to use this point and this point, and I'm going to connect the dots. And this one, okay, that line actually looks like it goes through the point at 14. I was really connecting the two yellow dots, 13 to 15, because those are the only other two dots I had on the graph. Now I was estimating here, so I did approximately, I called this 70 minus 57, 15 minus 13, so, 13 over 2, or 6.5 inches per year. I tried to pick the two closest points that I thought would be pretty similar to 14. What would you do if you wanted a better estimation? How would you get the best possible estimation? More accurate graph? Points that are closer? Points that are closer together? What if you really had, let's say your birthday's in June, what if you measured the height in May and July? What if you measured them really close together? You would get a better estimate. Okay, so now we're going to look at a little bit of definitions. The secant line is a line through 2 points on the curve. That's it. Secant line. Average rate of change is slope between 2 points. Right, that's change in y over change in x. It's the amount of change in the y variable and the length of the interval in the x's. Okay, now I've got two endpoints here. So that would be y2 minus y1. Just write the correct letter. x2 minus x1. But also in function notation, just f of b minus f of a over b minus a. Yikes. B minus a. Okay, and I'm going to highlight the secant line here because there's more than one vocab word. Secant line is the line through 2 points on the graph. The average rate of change is also called secant slope. All of these things, a lot of these words are used interchangeably. They're all referring to the line that goes through 2 points on the graph. If I actually ask for the slope, I just want the slope of that line. Maybe I actually asked for the equation of a line. What's the equation of a line? That's the equation of a line. Okay, so you're going to turn the page. There's a couple average rate of change examples. Go for it. Some of them are algebraic. One of them is graphical. Find the average rate of change means find the slope between those two endpoints. Giving you the x coordinates, fill in and find the y's. Okay, there's your slope formula. The A and the B, that's the 1 and the 3. A and B is the 1 and the 3 on that first question you're doing. Those are your x coordinates that are the 2 points you're looking for. Put some answers up here so you can check as you're working, and then I'll put some work up to tell you. There we go. So you can check. Right? And I put approximately because we might have different answers there. There's some estimation involved. It's all pretty close. Okay. In this particular example, okay, there's my line. There are my 2 points. Here's my line. And the only reason I'm going to draw this line, I see there's 2 ways that you could do this. I'm going to guess that this point is at 1450. That's where the estimation comes in. Is a point's not really labeled, I'm just going to guess what it is. So approximately 1450 minus 900 over 8 minus 5. And that's where I get approximately 183.3. Now, do you see that line that I drew? It's clearly going through the 2 points. Watch this. What if you do this point and this point? Is the slope between the 2 pink dots the same as the slope between the 2 yellow dots? I mean, they're on the same line. They should have the same slope. But that pink point is a little easier to read. Looks like it's 2 and 300, which looks like it should be the same as the slope between the 2 yellow dots. So maybe I estimate this way: 900 minus 300, 5 minus 2. It's approximately 2. Now, I'm guessing the 1450, guys, right? That's why it's a little bit different. Maybe it's close to 200. I would take anything that's off by about 15 to 20 because we don't actually know what the points are. I'm just trying to guess. Depending upon the one, you should have the work that shows how you got your estimate. Okay? Notice that this is 5 to 2, but it's clearly the same line. All right, let's do the last one. Does anyone have units that goes on the minus 32? Feet per second. Feet per second. Okay, so I'm going to show you how that happens. I'm going to graph this. I'm going to check it in my calculator. I'm going to zoom out. I'm going to get this point here that's 0, 100. Okay, might as well plot a few more points while I'm here. Okay. I mean, I could plot 0 to 4 at least. Okay. Window. 0 to 4. 0 to 100. Okay. There's my graph. Okay, so 0, 100. 1, 2, 3, 4. It looks like somewhere about here. It goes like this. Okay, so it goes like that. Now this is feet, and this is seconds. Okay. Average speed of the object from. Okay. Now this says speed. I would prefer that word to say velocity. And I will tell you why I prefer that word to say velocity. Okay, so we're going to do our 2 points. Okay, 2 is at 36. 4 is at negative 156. So I just labeled my points here. Okay. The average rate of change equals, okay, 2. 36 minus 100 over 2 minus 0 is 64 over 2. Okay. Notice that the slope of a position graph is velocity. What real quantity does your result represent? Velocity. It's in feet per second, miles per hour, velocity measurement. The slope of position, right? That's what I did. Slope of position is velocity. And then here's the line for the other one. The slope of position is velocity. If you are taking physics, that becomes kind of important. Okay.